Welcome to this video on word problems with quadratic equations. Let's begin. Example 1 says Jessica is on the balcony of her apartment, which is 150 feet above the ground. She throws her math textbook vertically upward off the balcony. The book's height, h, above the ground as a function of time, t, is defined by the equation h is equal to negative 16t squared plus 64t plus 150. Note that h represents the height of the ball in feet, and t is equal to the time in seconds. So you can do really whatever you want, but one strategy here is to draw a picture of what's happening. Okay, so we don't have that much room, so I'll just draw sort of a little picture here. So let's say this is a balcony, and here's a tiny little stick figure of Jessica, right? And she is throwing a book straight upwards, okay? So let's say the book is right here, so it's going to go up, right? Here's the book, and then the idea here, let me use a different color so we can see it better, right? It starts here, this is my initial height, and then it comes down, and I guess it falls all the way to the ground, okay? So I want you to note that this initial height here, let's see if I can use a different color, right? This initial height that it starts out is 150 feet above the ground, and then the implication is that it hits the ground at 0 feet, okay? The other things that we know, negative 16 is, this has to do with the acceleration due to gravity. It's an approximation, and this is the initial velocity. Okay, you don't really need to know all of that. It's a little bit extra, but I just wanted to demonstrate the fact that this is not traveling parabolically, right? It's not going like that because there is no horizontal displacement. Okay, if we want to see that sort of parabolic behavior, right? If you want to see that picture, well, then the x-axis would not be my horizontal displacement or my x, it would actually be time. Okay, so I really only see this parabola, this shape when I graph my height with respect to time. Again, I'm not graphing it with respect to, this is my x, my horizontal spacing. Okay, so it's not traveling at all in the x direction. It's just going straight up and then straight back down. Okay, and I know I kind of drew these two arrows, next to each other instead of on top of each other, just because I wanted you to see both of them. Okay, but if I was really being precise, it would go up and it would go straight down, just like that. It wouldn't move at all to the left or the right. Okay. So we have a picture, we have sort of a visualization of what's happening to this object, right? Again, it's going straight up in the air and then it's coming down, okay? So let's read what they want us to do, right? It says, how many seconds will it take the book to reach its maximum height, and what is the maximum height the book will reach? Okay, so what I want to teach you here, because you already know the math, right? You already know how to do things like find the vertex or find the x-intercepts, find the y-intercepts. So what I want to teach you to do is to translate these word problems into math, right? Into what is the math asking you, okay? So anytime you see the keyword of maximum, or sometimes it'll be a minimum, okay? Anytime you see maximum or minimum, I want you to think about the vertex, okay? This is asking for the vertex, okay? It might be asking for the x value of the vertex or the y value of the vertex. We're not sure yet, okay? But anytime you see that keyword, maximum or minimum, you know that you're going to be finding the vertex, okay? So let's read these again, and this time let's figure out whether we're trying to find the x or the y value of the vertex, okay? So it says, how many seconds? So let's come over here to this cute little graph that I have, right? So how many seconds? Is that time or is that height? Well, that's my time, isn't it? So they're asking for t, okay? And if I look at this function, right, is that acting as my x variable or is my y variable? Well, it's acting as my x or my independent variable, right? So if I have the point th, right, and that is my vertex, okay, I want to find my t, right, my x value, that first value of the vertex for the first part, okay? And then it says, what is the maximum height? Well, that's the h, right? So that's the y value of the vertex that we want to find here, okay? So again, the first part is finding the x value of the vertex. The second part is finding the y value of the vertex. They're both just finding the vertex, Okay, so we already know how to do that. The only new skill here, guys, is translating the question into math. Okay, and then the last question says, where does the book hit the ground? Okay, so when the book hits the ground, right, what is my height going to be? Well, my height is going to be 0. That's like my y value, right? So in other words, what time does it hit the ground? Well, if y is 0, isn't that just my x-intercept? Right? Look at that point. Isn't that just asking me to find the x-intercept? If I look at it on the graph, right, where it hits the ground, that's right here. Isn't that an x-intercept? Right? And we already know how to find an x-intercept. We just set y equal to 0, or in this case, h equal to 0, and solve for t. So once you break it down like that, it's really not that scary. Okay, so let's go back and see if we can remember how to find the vertex, right? So the vertex, if you recall, is the equation negative b over 2a. And if you're like, well, gee golly, what's a and b? Well, to figure that out, we need to go back to our original equation. So our original equation is h equals negative 16t squared plus 64t plus 150. So let's see if we can identify a, b, and c. So my a is negative 16, my b is positive 64, and my c, which I don't really need, is 150. Okay, so this is going to be negative 64 over 2 times negative 16. Well, that gives me negative 64 over negative 32, and that just reduces to 2, and notice my time is being measured in seconds. So my math book that I threw up in the air, right, will reach its maximum height after 2 seconds. Okay? So what is that maximum height? Well, notice, right, the maximum height that it will reach, what we have to do is we have to plug in 2 for t into that equation, right? And the equation is negative 16t squared plus 64t plus 150, okay? And then we're just going to substitute 2 and 2 and then see what we get. So 2 times 2, or 2 squared, is 4. Negative 16 times 4 is negative 64. So we have negative 64 plus 128 plus 150. So after 2 seconds, that book is going to be 214 feet in the air. Okay, so that is the correct answer. So again, all we really did, guys, is we found the x value or the t value and the y value or the h value of the vertex. That's all we did. And we already know how to do that. Then it says, when does the book hit the ground, right? Well, the book hits the ground when my height is 0. Okay, so we need to put in 0 for our height and see if we can solve it. So we're going to have 0 equals negative 16t squared plus 64t plus 150. So let's think about the different ways that we have to solve this. Well, one way is factoring, right? We can always use factoring. If we think that we can factor something, that's not going to give us irrational or imaginary solutions, but if it's factorable, we can try it. We can always use completing the square. And then the tried and true method, usually my go-to method because I know it works and it's easy to remember for me, is the quadratic formula. Okay, so remember that you have those 3 tools at your disposal: factoring, which again sometimes works, sometimes doesn't; completing the square always works but kind of a pain; and then the quadratic formula. So we're going to use one of those 3 methods to factor this and to solve for t. So as you can see, I just have absolutely no room at all on this page, so I clearly need to go to a new page. Okay, so as you can see here, I've already written my equation. I have negative 16t squared plus 64t plus 150. Now all these numbers happen to be divisible by 2. I could factor a 2 out if I wanted to, or I can just jump right in and do the quadratic formula. It's really up to you. Okay, you could also again try to factor it if you wanted to. I'm just going to take a minute and do the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have negative 64 b squared is 64 squared minus 4 times negative 16 times 150, okay, all over 2 times negative 16. So when we simplify the expression under the radical, we get 13,696, which isn't a terribly nice number, but that's okay. So let's see if we can simplify this a little bit more. So we have negative 64 over negative 32 plus or minus the square root of this whole mess, also over negative 32. Make sure you put both of them over negative 32 or you're going to be unhappy, okay? Because you're not going to get the right answer. So the first fraction is very nice. It simplifies to 2, right? So we have 2 plus or minus some stuff. And I don't believe 13,696 is a perfect square, okay? So at this point, I'm just going to go ahead and jump to giving you some decimal equivalents. Okay, so on my calculator, I have two solutions. I have a negative 1.657, and I have positive 5.66. Okay, so negative time just doesn't make sense. You can't go back in time to before the book was thrown, right? That's not meaningful or helpful. So the only answer is the positive answer, so it's about 5.66 seconds. And if we go back, I believe it asks us, it doesn't really say what to round to, so we'll just have to make a judgment call here. We'll just round to the nearest 100th, so 5.66 seconds. And that's the end of our first example. Okay, so again, with example 1, remember the main skill that I want you to get here is to take the questions and translate them into what mathematically are they asking you to do. Are they asking you to find the y-intercept, the x-intercept, the vertex? What do they want? Because if you can do that, then you're just back in the previous section where you're just doing all those things that we know how to do with a quadratic equation.
It's worth noticing that we can absolutely use Desmos to verify graphically the solutions that we got through algebra. So notice that I have entered in my equation here, y equals whatever, right? So let's interpret graphically these values. So the first thing we found was the vertex, right? So remember we said that our y value, the y value of the vertex is 2. So after 2 seconds, the book has reached its maximum height of 214 feet. And if we go back, we can verify this, right? We did get a maximum our maximum occurred at t equals 2 seconds, and that maximum value was 214 feet. So algebraically, we got the same answer as what we can see graphically from our vertex. The other values are our x-intercepts, which are both here, okay? And again, we disregard anything that happens before the time that she threw the book. And she threw the book right here at t equals 0 from a height of 150 feet above the ground. So we have 5.657, we rounded to 5.66, but again, we can go back here and verify that what we got using the quadratic formula is the same as what we get graphically when we see where the quadratic equation intersects the x-axis.
Here we have example 2. It says the formula p is equal to negative 0.001 x squared plus 2.45x minus 525 models the profit p from Mama Anna's restaurant lasagna meal each week as a function of x, the number of meals sold. Okay, so let's translate the questions. The first question says, how many lasagna meals should the restaurant sell in order to maximize profit? Okay, so your alarm bells should be going off in your head. We just saw that that keyword maximize. Anytime you see the word maximize, you should be thinking about the vertex. Okay, same thing here, right? What would be the maximum profit? Okay, so for this first one, I want to know the x value of my vertex. Okay, for the second one, I want the y value, which in this case is represented with the letter p, profit. Okay, so I want the independent variable of my vertex, that's x. Here I want the dependent variable of my vertex, p. Okay, and then this next one is a little bit different from the last problem. It says, how many meals, so that's x, how many meals would I have to sell in order to make a profit of $500? So in other words, when p is equal to $500, what is x? So guess what we're going to do, guys? All we're going to do is put 500 in for p. And then we're going to solve that quadratic equation. We're going to pull out our quadratic formula exactly the same again. So as you can see, I don't have that much room on this page. So let's just go to the next page. So what we first need to do is find the x and y value of the vertex. So recall the formula for the x value of the vertex is just negative b over 2a. So our a is right here, negative 0.001, and our b is positive 2.45. So we're going to have negative 2.45 over 2 times the quantity, negative 0.001. And I'm going to type that into my calculator and see what I get. So the answer is 1,225. So in other words, I would have to make 1,225 meals to maximize my profit. Okay, but notice not only do we want the x value of the vertex, which we just found, but we also want the y value of the vertex. In other words, what is the profit? What is the maximum profit that I can make? So let's see how we can figure that out. Well, what we really need to do is we just need to put that value, 1,225, in place of x, everywhere that x appears in this equation. And I kind of ran out of room there, kind of squeezed onto the next line. So we have 1225 here, we have 1225 here. Okay, so you can type that into a calculator, and when you do that, you should get about $975.63. Okay, so I want to show you that you can verify this graphically by simply graphing this equation. I didn't even write y equals. I guess the computer knew what I wanted. So this is Desmos, so you can see the equation is right here, right? And you can see the vertex, right? The x value of the vertex is 1,225. The y value is 975.625. I rounded that to the nearest cent since we're talking about money in the y variable. Okay? So the last thing they want us to do is to find x if p is equal to 500. So instead of p equals something, I'm going to write 500 equals negative 0.001 x squared plus 2.45x minus 525. So notice this is a quadratic equation. How do we solve quadratic equations? Well, we need to get 0 on one side. So I'm going to subtract 500 from both sides, and then I'm going to have 0 equals negative 0.001x squared plus 2.45x minus 1,025. So you can do whatever you want. For me, this looks like it's a job for the quadratic formula. So going past our graph, we have a quadratic formula. And as you can see, I've already identified A, B, and C. Okay, I've written out the equation here, and I found that the two values that will give me a profit of $500 are x equals 535 and x equals 1915. And I want to show you that you can also verify this graphically. But notice the equation that I would use is different. Do you see how C is now negative 1,025, right? If I go back here, right, this equation, right, is different from this equation, isn't it? Okay, so I can create this new graph, again, changing that y-intercept, changing this last value here, and I can look at the two x-intercepts. And lo and behold, those two x-intercepts are exactly the same as what I get when I use my quadratic formula. So let's do one more example. This one is about a tennis ball manufacturing company. They make and sell tennis balls, and their profit in dollars that they receive in selling X cases of tennis balls in 1 week is given by this equation. Okay, so again, X represents the number of tennis balls they sell in a week, and P is their total profit. Okay, so let's take a minute and just without doing any math, let's just translate these questions. So it says, if no tennis balls are sold, what will the profit be? Well, X represents the number of tennis balls sold. So this literally is just saying what happens when X equals 0. Well, when X equals 0, do you guys remember what that is? Well, that's really just asking me for the y-intercept. We know how to find that, right? Put 0 in place of X and then solve for y. We can do that. Okay, then the next two, right, talk about maximizing profit. Anytime you're talking about maximizing or minimizing something, right, that should set alarm bells off in your head and say, wait a minute, oh, we have to find the vertex, right? And you might even go a little bit further and remember that the equation for the x value of the vertex is negative b over 2a. Okay, so then let's keep going. It says use your graph to determine the number of cases of tennis balls that must be sold for the profit to be greater than 0. Okay, so we need profit greater than 0. In other words, right, we have negative 0.51x squared plus 102x minus 1500, right? That's going to have to be greater than 0. So we can just simply first set it equal to 0, right? This is, by the way, can you tell what this is? Right, when y equals 0, or in this case p equals 0, this is really asking me for my x-intercepts, isn't it? And we know how to do that, right? We just did that in the last two problems. We know how to set this equal to 0 and solve. Okay, we're probably going to have to use the quadratic formula again, just like we did last time. Okay, and the last two are almost the same, only instead of 0, right, it's going to be above 2,000 or above 10,000. So guess what? We're going to do the exact same thing. We're going to write the equation all over again. Look, this is getting boring because it's so easy. Okay, we want it above 2,000, so we're going to write greater than 2,000. Well, then what will we do? Well, we do what we did in that other example, right? We still get 0 on one side. Remember that? And we still have an equation where we have a quadratic on one side and 0 on the other side. And we could do the exact same thing here, right? Except for we have negative 1,500 and then we're going to have greater than 10,000, right? So again, subtract 10,000 from both sides. Okay, so guys, this is really nothing new. We already did all of this in the previous section. The only difference, the only new skill I'm teaching you here is to translate these word problems into math. And if you've noticed, I don't know if you've noticed, they're pretty much always asking you to either find a vertex or an x-intercept or a y-intercept. And you might argue, well, these guys aren't really x or y-intercepts. Well, they are, right? We just have to change the equation, right? We just have to subtract 2,000 and then find the new x-intercepts. Okay. All right, well, I guess we should probably go ahead and get started on this problem. So let's do x equals 0. That's easiest. So it says find. Okay, so I'm going to go on to the next page because I'm out of room. So I want to find the value of the function when x is equal to 0. Okay, so if this is 0, right, then this whole thing goes to 0. That goes away. That goes away. Well, guess what? I'm losing $1,500 if I don't sell anything. And doesn't that make sense from a practical standpoint? If I'm paying people to work in my tennis ball plant, right, and I'm spending money on materials and all that stuff, so I have money going out of my bank account and I don't have any money coming in because I'm not selling anything, it makes sense, doesn't it, that I would be losing money. So my y-intercept is negative 1,500, right? So my profit wouldn't really be a profit at all. It would be a loss of 1,500. Okay? So let's move on to the x and y value of the vertex. So I'm on a new page here, and you can see I copied down the equation. So the x value of the vertex, again, is negative b over 2a. This is a, and this is b. So I have negative 102 over 2 times negative 0.51. So that's going to give me 100. Okay, so the x value of the vertex is 100. Now we have to find the y value. Well, we do that by simply substituting 100 wherever I see x in the equation, and then solving for our p, our profit. Okay, so I'll put 100 here and 100 here, and then let's see what we get. So as you can see, I've done the math here, and I have a profit of $3,600. Let's show that we can verify that graphically. So notice here I have typed the equation into Desmos, right? And Desmos is showing me this vertex, right? And again, it agrees with what I found. If I sell 100 tennis balls, right, or sets of tennis balls, whatever they are, right, 100 units, then I will make a profit of $3,600. And as you can see graphically, that is the maximum profit according to this model that I can make. So let's go back to the original question, and let's just check off the ones that we've done so far. Okay, so we did this one, right? This is really just finding the y-intercept. We hardly had to do any math for that, right? We could just look at the equation and identify the y-intercept visually, right? Then we found the x and y value of the vertex. Okay, so the next three are almost identical. If we have to do this algebraically, we have to use the quadratic formula for all three, right? So the only difference here is one is the profit greater than 0, profit greater than 2,000, profit greater than 10,000. So let's see how to do that. So if we want to do this algebraically, what we need to do is the good old quadratic formula. So this is A, and this is B, and this is C, right? So we have negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, so we can compute that. We can also look at the graph. So let's cheat and look at the graph. So remember, what are we finding here? If y equals 0, we're finding x. What are these called? These are called the x-intercepts, where the graph crosses the x-axis. So if we go back, right, what are the x-intercepts? Well, they're right here and right here. Right, so if we want to keep the profit positive, we have to manufacture, and let's remember we can't manufacture part of a tennis ball, so we're going to round this to 16, and we'll round this to about 184. Okay, so if we want to keep our profit positive, we are going to have to manufacture between 16 and 184 tennis balls. Okay. So again, you can type that in and you can compute it, you can fact check it and make sure that it's the same as those values that we got graphically. So this problem is almost identical, right? Now it's saying, well, what do I have to do to keep the profit above 2,000? So remember, mathematically, if I'm trying to solve this, what I'm just going to have to do is I'm going to have to subtract 2,000 from both sides. So I have this almost identical equation, except for the y-intercept has moved up to 3,500. Okay, so again, I can, put this in for A, put in negative 0.51 in for A, put this in for B, put this in for C. I can crunch those numbers, or I can cheat, and I can graph this new equation. Okay, notice this, right, is exactly the same, except for now I have minus 3,500 instead of minus 1,500. So I have some new x-intercepts here, right? So according to this, I would have to make between 44 and 156 units. Okay, so we can write that here, right? Between 44 and, what did I just say? 156 tennis balls or tennis ball units. Okay. So the last problem says find x when p is equal to 10,000. So again, you could think about doing it this way, right? So we would have this is negative 0.51x squared plus 102x minus 11500, right? So we have this new equation, and we can graph him if we want to. Okay, notice what happens when we graph this guy? Well, he doesn't even have any x-intercepts. But that makes sense if we go back to the original graph, right? Let's look at the original graph. What is the maximum profit that we can make in this business? Well, if the maximum profit is $3,600, is there any way at all that I can keep the profit above $10,000? No, right? Because I can't make it go any higher than this highest point, which is $3,600. So a simple answer to this is that, there is no solution. Okay, if you wanted to be a little bit more thorough in your explanation, you can say that the profit cannot exceed our maximum, right? And our maximum, we said, was $3,600. Okay, so again, if our model is right and if it's true, we can't achieve a profit of more than $3,600. So there is no X. There is no amount of tennis balls that I can sell, again, according to this model, that are going to make my profit be anything more than $3,600. Certainly not $10,000. So that's it, guys. So again, I want to encourage you guys and remind you, anytime you see these word problems, the first thing I want you to do is to translate. What are they really asking you to do, right? All we did, it sounds like a lot of words, it seems kind of scary. All we did, guys, is find our x-intercepts, our y-intercept, and our vertex. That's it. Okay, so word problems, they seem scary at first, but they're really, really not.